Hello friends, my name is Mayank and welcome to my YouTube channel and another video of Advanced Rag. The source document for this demo is NeurIPS 2020 paper Retrieval-Augmented Generation Knowledge for NLP task by Lewis et al. Published at Facebook AI Research. We will index this paper and run real query against it. Today, we are going to use Weaviate, a cloud vector database with built-in hybrid search capability, and we will add Cohere Reranking API on top. By the end of this video, your RAG pipeline will not only retrieve the best documents, it will re-rank them by relevance before sending them to the LLM. This is one of the cleanest production grade pattern you will see in enterprise RAG systems today. So let's get into it. So don't forget to like, share and subscribe. Let me start with a quick recap of what hybrid search actually means, because this is the foundation of everything we build today. Hybrid search combines two retrieval strategies. The first is keyword search using BM25. This is a classic information retrieval algorithm that looks at exact word match and term frequency. It's great when user type specific terms. The second is semantic search, where we convert text into dense vector embeddings that capture meaning, not just keyword. In Weaviate, both of these happen inside the database itself. We configure alpha to control the balance. Alpha 0 gives you pure keyword result. Alpha 1 gives you pure semantic. Alpha 0.5, which we will use, gives equal weight to both. The really nice thing about Weaviate is that it bundles this complexity behind a single class, Weaviate V4 Hybrid Retriever. Let's look how it fits into our architecture. Let me be direct about why a nav RAG pipeline is not good enough. If you use semantic search, you might miss documents that contains the exact keyword a user typed. If you use only keyword search, you will miss the documents that are conceptually related but use different words. So, hybrid search fixes the first two problems, but there is a third issue. Just because a document is in your Top-K retrieved result doesn't mean it is the most relevant to the query. Top-K retrieval is approximate. You might get 4 chunks back and only one of them is actually useful. This is where Cohere's re-ranking APIs comes in after hybrid search returns. Say 4 documents, Cohere re-scores every document against the exact query using a cross encoder model, which is far more precise than the original retrieve step. The result is re-ranked list where the most relevant document rises to the top K with a very high relevance score. In this demo, we will see top relevance score of somewhere around 0.38 from Cohere Reranking version 3.5 on the demo query. Alright, let me walk you through the complete pipeline architecture for this video. I want you to understand exactly what happening before we touch a single line of code. The diagram has three phases. Phase 1 in the blue, phase 2 in the green, and phase 3 in the purple. So let's go through each one by one. Phase 1, this is everything we do before a single query arrives. We start with Weaviate Cloud Cluster. The oval shape means it is an external service. We create a free sandbox cluster to console.weaviate.cloud. This is our vector database. It will store our rag paper pages and make them searchable. From there, we set up a credential, the Hugging Face token, and API keys. If you notice, we set this in the Google Colab secret. For all these, we never hard-coded credential in the notebook. Then we define the collection schema, class name in RAG vectorization is text to vec. Hugging Face embedding model is BAAI slash BG hyphen base hyphen EN version 1.5. This tells Weaviate whenever a document is indexed, generate its embedding using this model on Hugging Face API server side. We don't manage embedding locally. And finally, Weaviate V4 Hybrid Retriever, our custom retriever class equals alpha 0.05. This is most important fix in the whole episode. The standard Weaviate Hybrid Search Retriever from LangChain community is broken with the Weaviate 4 version 4 client, so we retrieve our own. Notice the arrow from there going down to the phase 2. That bridge is intentional. The retriever we set up here is the same object that executes queries in phase 2. Phase 2 hybrid retrieval. This is what happens every time a user sends a query. It starts with user query, another oval, external input in our demo. That's what abstractive question answering taken directly from rag paper. Now look carefully. The query is split into two parallel branches simultaneously. This is hybrid part. On the left hand side, we have BM25 sparse keyword search. This is exact word matching BM25. Look at the term frequency and term inverse document frequency TF IDF. It's great for exact terminology. If your query contains a specific technical term, BM25 will find pages that contain that exact word. Come to right hand side. Right branch tends embedding semantic search. This converts the query into a vector query into vector using the same embedding model BAI slash BGE base EN 1.5 model and finds the page the similar meaning even if the exact word doesn't match. Both branches feed into Fusion Weaviate using reciprocal rank fusion RRF to merge the two rank list. The alpha parameter controls the balance at alpha zero point 0.5. Both sides get equal weight. The alpha 0 is its pure keyword. At alpha 1 it's pure semantic. The fusion produce a Top-K ranked list. In our demo, the top 4 documents from rag paper, these are the 4 pages we will consider most relevant to our query. Phase 3, Rerank and Generate. We now have 4 candidate documents. Phase 3 improves the quality before the LLM sees any of them. First, Cohere Reranking API. We call model Rerank version 3.5 from the LangChain Cohere package. This is a cross encoder model. Unlike the bi-encoders used in phase 2, which encode query and document separately, a cross encoder processes them together. It has much more context from judging relevance. In our live run, Cohere returned score something 0.64, something like this, or we will have a top 3 documents out of it. Between rank 1 and rank 3 is the filtering signal. Without re-ranking, you have no idea which of the 4 documents are most relevant. The contextual comparison retriever. This is the wrapper class from LangChain classic.retrieves that combines the base retriever and the re-rank into single interface. When you call it, it retrieves your data or questions answers from the questions using Weaviate, then immediately compresses and rerank using Cohere. The LLM only see the top re-rank document, and then Qwen3-8B loaded in NF4 4-bit quantization via bits and byte config. This replaces the original Cypher 7B beta which we have used in the previous video. Apache 2.0 license, stronger reasoning fits in approximately 5 gigabit of VRAM on a free T4 Collab GPU. We use non-thinking mode, do sample equal to false, and for direct factual answers. And we will get the output, the final answer with the relevance score. So this is the another oval back to the user. The document is scored 0.664 on our live run, which I have run earlier. The LLM receives only the highest quality context and generated a focused answers. Let me give you a quick summary or I can say one-liner summary for an entire diagram. Phase 1, setup Weaviate and customs retriever. Phase 2 runs BM25 and semantic search simultaneously, fuses the result with alpha 0.5. Phase 3 re-rank with Cohere pass only the top documents to Qwen get a precise answer. 3 phases, 2 retrieval models, 1 ranker, 1 re-ranker, and we are query the paper that invert this document. So let's go back to our PPT. Before that, I just want to show you. In the previous video, I have executed this notebook. Before committing to the GitHub, I have added proper comments like this so that it will be easy for you guys to understand, and whatever I have discussed in the previous video, I have already put step by step here in this notebook. So you will have a better understanding what step is doing what. Let me make it a big for you. I hope you can read it. So before each step, whatever I have discussed in the previous video or previous notebook, I have added up here. Similarly, I will do it for this video's notebook as well. In fact, I have already done for this notebook, this video's notebook for all this. So I have execute the same with the proper comments. I hope you will like it. So this is the same architecture pipeline which we have just discussed. The another representation here, however, it is not that much graphical. It's just a fits in PPT, PowerPoint presentation. Similarly, we have divided into phase 1, 2, 3. In phase 1, we are doing setup and index. Phase 2, hybrid retrieval. Phase 3, re-rank and generate. So let's move to the next slide. So now we are building a RAG system that invented RAG. I like the meta quality of that. For our 2 test queries, we are directly comes from what is abstraction question answering, from section 3.2 of that paper. What is the RAG token? Section 2.1 of that. These are real research questions that with real answers in these. We will see exactly how well hybrid search cohere ranking finds the right passage. Important note on the number. The actual number coherence relevance source from our live run on this video and earlier could what we have discussed in the PPT and the other places in the architecture diagram, maybe it could be different. So whatever the numbers could come, it could be comes actual now. That numbers what we had that it was some previous run, maybe the document could be different or something else, or maybe I have wrongly questioned. So that one was that. So let me start. So first thing, this is the pipeline. These are the table of contents. So first thing, let me connect with GPU, change runtime. This is connect, save. Now let me connect. Also, I have to be ensure after that connecting, I have to put that actual. So now actually I have uploaded my document to this path storage. All my keys are also here and I am also connected. So let's start. Let me install all the packages first. We have Weaviate client, LangChain, LangChain community, LangChain classic, PyPDF, bits and bytes, accelerator, Cohere ranking, all installed. So you cannot see now because I already installed all the packages. Now let me import Weaviate and Weaviate clients, Weaviate libraries as well. Now I need that Cohere Weaviate and Cohere keys as well here. So I have Weaviate key. Let me verify and do it. Let me check. To get the Weaviate API keys and URL, you have to go to weaviate.io. If you have your account, you have to log in and get the clusters and URL. If you don't know, then you can create. First, you have to log in. Maybe first time you need to register. It is very easy. You can choose either Google or your GitHub or with anything email ID you have, you can do that. So I am using my Google account. So once that login done, I'll get this kind of page. This is when I have already created a cluster. So first time you have to create a cluster. Once you will have a cluster, you will get a cluster here or you can create a new cluster here. You can, I think you are big, you can figure it out how you can create the cluster. So this cluster once you create, it will be available only for 14 days. So I have created earlier this cluster and you can see it already have some data. Here you can get an API keys and your how to connect. Here is that button how to connect. If you click that how to connect, you will get your Weaviate URL, your API keys. API keys you will get from there, your Weaviate URL you will get from here. You can also take the code here. You can also get your code here to copy paste. If you don't need, you can get that code for Java, Go and TypeScript. All three codes you can get it. For Python. So we are working on Python, so you can get it there. Once you get it here, you can see that all these things are available and your key is available. Key, rotate your key or edit your keys, and you first time when you create, you can copy it. So that keys you can get it. I hope you understand And let me see if I can show you something else over here. Databases. I have one collection already here. We can explore data. You can say that the data has been chunked and reside here already. However, when we do it again, this will be the same lab. We will delete and do it again. Embeddings, it is using embedding for this. Use it for production or for the RAG model or something. You can use pricing and you can see the pricing billing and you can. So let's go back to our notebook. So I have added my API and cluster UI. There was a one more was there which I deleted. This. So now let me get this API key. I have to grant access for both. Now I need Hugging Face tokens. First I'll get the. So I have all these things. I have a Cohere API key. Let me also to show you that how we can get that. To get the Cohere API key, you need to go to dashboard.cohere.com and again you have to sign up or log in. If you have already have an account, you have to log in. If you don't have, you have to sign up and get login and then you can get the keys. I already have the account, so let me log in. So once you will log in, you will get this page and that you can see playground. You want to run your queries and you want to test it, you can run it. You can choose model from here. So this is we are not doing right now. Go back to dashboard. Then we have a data set, API keys. We need API keys. You can get this API keys. You will get it. You can see that API keys and you can copy your API keys and configure there. Data set, nothing is there. Vaults, nothing is billing and so in billing and usage, you can see one trial is we have done that on 8th of June. So we are doing it again. So we will have this. Please keep in mind when we will do it. So we'll get this another row or another data here. So if you want it for production or something, you need to get your production key. That will be chargeable. So here and there will be a lot of features which you can play around if you have a production keys. So here we are just for we don't have that keys available. However, we can see somehow that how we can get our work done and we can see some ranking site. We getting the ranking, we'll use our notebook itself. That something is happening and how many quantities, how many re-ranks will happen, we can get it from here. So just copy your Cohere key and paste it in your create in your notebook. Now let me break down each key component so you understand exactly what you are importing and why. The Weaviate V4 Hybrid Retriever is the star of the retrieval phase. You configure alpha for the keyword semantic balance, point it at your index name, and it handles everything. Bits and bytes config is how we load Qwen3 without running out of GPU memory. NF4 is a special quantization format designed for language model. It keeps accuracy high while reducing memory from about 14 gigabyte down to around 5 gigabyte. That's what makes it feasible on a free T4 Collab GPU. For re-ranking, we use Cohere Reranking. wrapped inside a contextual comparison re-ranking. Think of it as wrapper that says retriever document using the base retriever, then compress and re-rank them using the compressor. The output includes relevance score. Finally, the retrieval QA chain connects the compressor retriever to the LLM. Important note: import this from LangChain Classic, not from the standard LangChain library. That module was moved. Let me give you an analogy that I think makes the whole pipeline click. Imagine you walk into a library that asks, give me a book about neural search. The librarian that Weaviate search both the index and the subject catalog simultaneously. That's hybrid search. She begins back 4 books. But now you have 4 books and you are now sure which one of the most useful. So you call in an domain expert. That's Cohere Reranking. She need she read all 4 books, score each one, and says book 1 is 99% relevant to your exact question. Book 2 73%, book 3 41%. She hands you the best one. Now you pass those best pages to your brilliant research assistant. That's the Qwen3. Because the context is high signal and low noise, the assistant gives you a precise, trustworthy answer. That's the entire pipeline in one analogy: library, retrieval, expert review, answer. Please like, share, and subscribe if you like my videos. Let me make the improvement concrete with a direct comparison. Without re-ranking, you are using either semantic or keyword retrieval with no relevance score, and all top-K chunks go directly to the LLM, including the noisy ones. The LLM might produce a verbose answer that mixes up relevant and irrelevant information. With our hybrid pipeline and Cohere Reranking, you get a measurable relevance score. In the live demo, we saw some score 3.3884 as the top score for the query about abstractive question answering. Cohere ranking score range from 0 to 1, 0.0 to 1.0. Most importantly, only the highest score documents get passed to Qwen3. Less noise going in means better answer coming out. The quantization also deserve a mention. By loading Qwen3 in NF4 4-bit format, we reduce the VRAM requirement about 14 GB down to the 5 GB. That's what makes it runnable on free T4 Collab GPU. So after getting your Cohere key, you have to just create a variable here, another one, your Cohere key. Once it is available, you can just do it again. I'm doing it again because it took some time for me to here to there. So I'm sure that everything is done already, so I've just doing again. So fine, my Cohere key is also there. Now I am just connecting to Weaviate client using API keys here. So I am connected to client is ready. My Weaviate client is ready. So as I told that I have done that page ranking and all. So this is I am already using base this. So here this code what is doing currently I have already have a rag collection available. I'm just deleting it and creating a and then I'll create another again that collection. So I'll delete first and I'll go back to my Weaviate client to see that my collection has been deleted. So my collection has been deleted. Let me go and search, check there. So you can see now I have my cluster, but there is no collection right now. And my collection has been deleted. Now let me go back. Now I am just again doing the client ready and then to the collection, create that collection again. So I already have a client. Then again just connecting. Okay, just again I am doing that collection, create collection. So my collection will be create and using this model. Earlier we have used all mini LM, but now I have upgraded to the latest updated model. Let me create. So let me see if the client has if the rack collection has been created. Now let me refresh. Let me refresh. I'm refreshing my Weaviate client and see you can see that I already have one rack collection available now. Guys, here I have already deleting this one earlier also deleting. So it's just a double check that whether have been deleted or not. So I think one code is enough. You can delete the other one. I am not going to delete you to sake of that. If you have to delete, how you have to delete, if you only have to delete, you can keep this one for your reference. One more thing, once you have that collection available, you can check what is inside. So we have used this model, embedding model, for creation our collection, which is matching with our model here. We can see that, and even if I'll go to Explorer, I'll not be able to find anything now. There is nothing. If I'll click here, there is nothing available, nothing query. We don't have anything. Only we can see that now again index has been there, index type and all these things are there. Model name is there and the name is documents for rag, which is similar for our with our thing. Document for rag, description, vectorization, and this is for. So now let me go back to the another one. This is the most important code change in entire notebook. Weaviate Hybrid Search Retriever from the LangChain community is broken with the Weaviate 4 client. It uses the old version 3 APIs internally. We write we write our own retriever class that subclasses base retriever and calls collection query hybrid directly from the version 4 API. You can see after I executed, you can see the warning there, deprecated warning, pedantic warning, deprecation warning about class base config, safe to ignore. So we can ignore that. So full three phases architecture. Phase 1, custom Weaviate retriever, version 4 retriever. Hybrid Retriever phase through BM25 plus Semantic at alpha 0.5, phase 3 Cohere Reranking version 3.5, then Qwen 8 billion source document on the paper. Im- we we have import now, import torch transformer Hugging Face. You will see the LangChain community sunset deprecation warning. Expected to save and proceed. Model name, we are using Qwen3-8 billion. Alibaba 2025 model Apache 2 word license 125k context. Stronger reasoning than Cypher 7 billion beta, which we have used earlier in the old video. So after that we have a load quantization, NF4 bit quantization via bits and byte config. This loads Qwen3 in approximately 5 GB VRAM instead of 14 GB. This difference running on a free tier T4 GPU and needing an expensive GPU. No boss token ID override needed as old one for Qwen3. Unlike Cypher 7 billion, which required explicit boss token ID, simple auto tokenizer load here. You can see the progress bars, tokenizer, config and vocabulary files downloaded from Hugging Face Hub. So there was the few cells which I have run it in offline, and I was predicting that a video is running, but it was off. So I have just done it again. Those parts which we have done again basically. This part took around some time. So loading in the GPU memory for the N4 quantization. The paper we are indexing reporting that RAG sequence achieve 44.5 exact match on natural questions. So you can see that we have loaded around should reach to 16 GB, but if you see it, it is around somewhere 5 GB. Let me see if I can show you somewhere. GB download completed. Everything is downloaded. Okay, let me see if there are any files. Let me refresh. No files. Okay, so now I'm into Hugging Face pipeline. 4 keys classes for the bits and bytes, Cohere ranking from LangChain, Cohere Retrieval QA from LangChain. All this, let me execute this. Now execute, get the output from there. I believe now I can see that which we have already done. Text generation pipeline with do sampleization, non-thinking mode for rack critical do not pass temperature Top-K Qwen3 pipelines silently ignore them and generates warning. The following generation flag are not valid and may be ignored. Use do sample equals to false. Wrap the pipeline as a LangChain project. Do sample is equals to false. And this one done. Now let me load our document, which is basically retriever augmentation generation for NLP PDF. Let me execute this. PyPDF loader is for the RAG paper. This file is RAG augmented generation for NLP. Make sure that you have uploaded it into the Colab storage content folder directly before running the cells. So we have to ensure. Output shows the page content. This PDF has 19 pages, including appendix, which each page becomes one document, one chunks in the Weaviate. So this has been indexing 19 pages into Weaviate. The original rack paper indexes 21 million Wikipedia chunks. We are doing exactly the same thing, just at demo scale. The, the architecture is identical. Now we see the document 6. Any document you can see, basically it's page 6. So page 6 contain open domain QA results table, and beginning of the abstractive QA section 3.2, you can see the whole text from there. This section 4.3 and 6.3. This is the version. So you can see the document very well over here. Is this okay? Now execute this. So we are reconnecting with client Hugging Face header batch index. Critical step, two things happening here. First, we reconnecting to Weaviate client with the Hugging Face IP API keys header. This is required. Weaviate need to call the Hugging Face API to generate the embedding model, with our embedding model for each document as we indexed it. Second, we use collection batch dynamic. The batching API retrieved add documents and output the document indexes in the Weaviate embedding. All 19 pages are indexed now. Let me see in the somewhere in the Weaviate if possible. So now you can see in the Weaviate we can see the data. Now go back, we can see the data in the Weaviate for all 19. I cannot. There are 2 pages. Each page have 10 rows. So I believe this is only 2. Then it is 19 only. We have seen that. Now we are just reloading all the credentials again, in case it is reconnect required. Grant access to Hugging Face rights. So now we are using write access to from the Hugging Face. Reinitialize the Weaviate Hybrid 4 retriever with the client that has Hugging Face header. This is required so the hybrid queries can also call Hugging Face API to vectorize the search queries itself. What is RAG? And output will be of document 4. Let's see. So here we are just querying our what is RAG token. So retrieve document 4. Hybrid retrieval confirm working. The first result should contain content from section 2.1. The RAG token models description. Now we have a hybrid chain merge. The library analogy Weaviate is the library of NLP papers. Cohere is the expert reviewer who reads and scores each paper. Qwen3 is the research assistant who needs the expert curated pages and generates the answer live score from our run. Let's run this one. We have import. So it's a simple prompt template context. Then question, then answer. Baseline chain uses the raw retriever, no re-ranking yet. This is our complex baseline. What is abstractive question answering? Then directly from the section 3.2 heading of rack paper. Watch output closely. Let's run it. Qwen3 echoes an full prompt and all retrieved context before generating the answer. You can see template is complete showing it. This is the normal baseline behavior. All four retriever chunks go into the prompt, including the retrieved relevant ones. Output is verbose. Qwen3 thinks through the context before answering. Generate MCQ style repetition at the end. The core answer is correct, will be correct. Mention, let's see, task and free from text generation from the section 3.2. Hold, just hold on. We'll compare against the re-rank versions shortly. At the time it is executing, I'm just showing that Cohere ranking side is nothing. Re-ranking side, it's only one row as earlier. We don't have anything in the billing and usage now. So only one row, which is on 8 June. Let's go back to our original while it is running. I believe that was completed now. So this is completed. All four retrieved chunks go into the prompt, including less retrieval ones. Output is verbose. That's what we have discussed. And generates MCQ style repetition at the end. The core answers is correct. Okay, now let me go to the next one where we have already seen the Cohere ranking. Now let's do that. So we have to compare before and after queries from the paper. What is the rank is coming, and we need to find out the rank. So here we are just importing LangChain retrievers contextual. This one is not correct. Let me correct this one. I have corrected this one. My library is correct now. So basically not, it's from LangChain Classic, not from LangChain. That's the only change I have done. And here again I'm accessing my Cohere ranking. Model is Rerank 3 version 3.5. Always specify explicitly, never leave unset. And top n equals to 3. Contextual compression retriever wraps both base retriever fetches document first and then the compressor re-scores them. Re-rank print score, or let's see, this was the old one. Let's run that and see that ranking. Now we have a ranking of relevancy score 6.46641. Okay, let me correct it. And this one. So let's talk about what is these means. 664.664 for rank 1 Cohere cross encoder is highly confident this document is relevant to the query. 0.3853 for rank 1 is still relevant, closely secondary. 0.0860 for rank 3, much less relevant, nearly 8x lower than rank 1. 8x gap between rank 1 and rank 3 filtering signal re-ranking gives up without re-ranking. All three chunks would receive equal weight in the LLM context window. With re-ranking, only the top two high scale chunks are prioritized. The 0.086 chunk is excluded from the prompt. Now let's go back to our Cohere and see the billing there. Let me refresh this page. Okay, it's already refreshed. I can see that. So you can see that here we have one quantity here, trial, default, and then one re-rank. Today's date is billing is 0. Our code called Rerank 3.5 and cost 0. This is live proof that API was called. The score is 0.664, 0.3853, and that what we saw in the notebook. These come from this API call Cohere Cross Encoder processed our query and all retrieved papers, all 4 retrieved papers pages together and gave us back these relevant scores. That's why re-ranking is more accurate than retrieval alone. The cross encoder sees the queries and documents simultaneously, not separately, like a byte encoder. Now go back to our now re-rank chain. Same chain structure as baseline, only change the compression retriever instead of raw retriever. Everything else identical. Same query. Compare now the same query. Let's see. Re-rank chain passes only top 2 re-ranked chunks. Let's see. To Qwen3-8B and the not relevant one 0.806 chunk will be excluded. Less noisy. Going Qwen3 generates the more focused answer about abstractive QA generating free form natural language answer rather than extracting span tested in task. In PPT, the 6.06641 that input is different than this one because that one runs for that PPT have been created while that run was different. The, the file was also different, and then I realized that file is different and I corrected the file and run with this file. It was okay. So there could be a number differences you can find. However, that you have to test in this notebook, and PPT is just for knowledge purpose, which would be helpful. So the same thing but different outputs. So the answer, let's see, run this one. What is the rank? The answer should explain the rack token model drawing a different latent document for each target token and marginalizing accordingly, allowing the generator to combine content from several documents with producing an answer. This is the section 2.1 of the document. The test confirm our hybrid retrieve correctly. Surface section 2.1 content of for the query using the exact terminology of the paper. Let's wait. So I have done this again before, so that's why I have tell everything now. So now you can see that it's only showing this one, the old one already gone. Now everything is on 15 June today's. So while I moved and I checked, it was just in the transition phase from my system or from Google Colab to Cohere ranking. So that's why it took time, and now you can see that quantity is also 3 and re-ranks past 7 days. If I'll search, I'm not sure if I'll have that. That was on 8th of this. So now you can see that all 3. So this was the first one, which was 3348 something like, and this one is these two are same 664. So here is the output. So what are the key takeaways? I have also this was the old values which is not corrected. I'm not going to correct now, and I think you can understand. So there are some changes what we have discussed over the lab execution and the pipeline execution, and then values. Uh, these values I'll try to correct it, and I'll upload into the SVN as well. So now go back to our PPT and complete that the whole key takeaways and what we have learned from the past few cells. Uh, Anything else? Nothing. Fine. So we cannot see anything much on the Cohere side now because we are just using our trial version. However, if it's a production one, it could be different. So let's go back to PPT. Let me anchor this with some concrete numbers and real world context. We saw a top relevance score of 0.3848 in our live demo on the rack paper. That score tells us Cohere Rank Cross Encoder found two documents equally relevant, both 0.348 and one much less. So, the source paper itself report that the RAG retrieves on gold evidence document in 71% of fact verification, and in the top 10 in 90% of cases. Our demo is validating retrieval quality with the very paper that introduced RAG. The That's not magic. That's Cohere cross encoder model doing precise pairwise comparison between the query and each document. The closer to 10, closer to 1.0 and more relevance. The NF4 4-bit quantization is a massive practical win. You are loading a 7 billion parameter model in approximately 5 GB of VRAM instead of 14 GB. That's the difference between run on a free GPU and requires a paid A100. And the hybrid search approach, two retrieval strategies in a single API call, is exactly what enterprise RAG systems use, whether you are building document, Q&A, and law firm. A customer support bot that needs to match ticket ID and understand intent, or a medical knowledge base that exact drugs names matter. The pattern handles all of it. Please like, share, and subscribe. Let's land the key lesson from today's one. Weaviate Hybrid Search retrieves does the heavy lifting of combining BM5, BM25, and semantic search in a single cell. The alpha parameter is your dial 0 for keyword only, 1 for semantic only, zero point 0.5 for balanced. Cohere ranking adds a precise layer that BM25 and semantic search simply can't match on their own. You get the actual relevance score 0.3 Qwen3-848 is the actual top score from the live demo. 3. NF4 quantization is not just an academic trick, it's the practical key to running production grade 7 billion model on budget hardware. Use LangChain Classic for the retrieval chain components. The standard LangChain package removed. The complete notebook with all line on inline commands is committed in the GitHub link is in the video description. Today's recording used clean code explained verbally. So the number could be changed. You can find the difference what I am saying in the video and could be in the while I was running the notebook. The GitHub version has the full documentation. Source paper for this demo augmentation generation for knowledge for NLP. All test questions queries from the paper sections. In episode 3, we were going to build a custom re-ranker from scratch and look at the flash rank. LangChain you own re-rank options. This is it from my side. I am Mayank Chuk. Thank you so much for watching. Please like, share and subscribe. It really means a lot. I'll see you in the next video. Take care. Please like, share and subscribe. Thank you.